Today, we're going to review the gateway tools for operational decision making. So we just spent time talking about action thresholds, and now we're going to demonstrate how the gateway can be used to calculate and monitor the metrics that may trigger intervention. So, of course, when you're making your operational control decisions, you're making them for a specific spatial area and a specific time. You're often not doing this on a whole agency level. It might not tell you much if across my whole agency I collected this many mosquitoes per trap night, but if I'm looking in a specific neighborhood or a specific region and noticing that my mosquitoes per trap night are much higher than normal in this specific region, that may trigger the action or the intervention. So when you're running these calculators in the gateway, there are two ways to attack this. So you can choose a spatial region by drawing the region on a map each time you run the calculator. Or you can create a spatial feature and save them to your account so that you'll be able to run those same spatial features over time. So first, we're going to go over creating spatial features really quickly and then using the calculators. So here we are in the gateway. I'm using the sandbox. And if you're not familiar, the sandbox is a copy of the VectorServe gateway. It's a playground environment where we can add, edit, play with data, and it's not actually going to mess with any of our actual information or actual data. So it's just our playground environment. So when I'm doing this training, or maybe if you are trying to create spatial features or use these calculators for the first time, you may want to do this in the sandbox so there's no risk to actually editing the data that's in the system. I'm also in CalServe because we are using Sacramento YOLO mosquito control districts data. They've been very kind to let us use that for training purposes. So let's go over first how to create spatial features. So here we are under tools. This is where our calculators live as well as our spatial tools. So we are first going to go to spatial features. And this is how we are going to create features for our agency. So the way that there are multiple ways that you can do this. You can draw on a map. So let's go ahead and do that. We'll draw a spatial feature in my old neighborhood where I used to live. We're going to add a polygon and we are going to add a spatial feature. You can zoom in to have higher resolution here if you want. We're just going to go make this for this whole Tahoe Park, Elmhurst region. So there's my polygon that I've created. I can name that polygon. So I can call it Tahoe Park / Elmhurst if I want to. There are two questions here, share with agency. So this could be, if I don't want to share it with the agency, I'm just creating the spatial feature just for myself and for my account. But if other folks in your agency are going to also run these calculators, you may just want to share it with the agency. There's a question, is this feature appropriate for public maps? This actually doesn't do anything at this moment. The thought was maybe that we were going to create maps and incorporate these, but we haven't done that. So I can just go in and save that feature. So it gives me a green box up here saying the active feature Tahoe Park / Elmhurst, Elmhurt has been saved successfully. I'll show you that we can actually change that. So down here, it's showing me all of the spatial features that have been created by my agency and shared with the agency. If I want to just search for what I'm creating, this is what I just created, Tahoe Park / Elmhurst. I can edit this if I would like to. Okay, and change the name to Elmhurst. Save. There we go. We edited the name. So that's how we create spatial features by drawing polygons. You can also draw multiple polygons for the same spatial feature. So if you were interested in, let's go create a new feature. If I want to create this region plus this, I can create these as one feature. So you may have a region where you're treating two rice fields near each other, but you only want to see what's happening specifically in the rice fields. You can do that. Another way to do this, I have this collapsed right now, but if you collapse back in so that we see the sidebar, there are ways for you to import features. So instead of going through and drawing them each on a map, you could import features using Esri shapefiles. And if you need some information on spatial features, this dropdown will tell you a bit about spatial features. So now that we've created a spatial feature, we are going to go.
Sorry, question.
Yep.
Okay, so these two polygons are under that one.
Yeah, I actually haven't saved them yet, but I can
Okay.
do that. Double polygon. And then I want to share it with my agency and I'll save the feature. So now,
Have to.
yeah, so when we go back, reset this page, my double polygon is telling me there's two, but it's still just one feature. So at any calculation that I run in this double polygon feature is going to run for both of these. If I wanted to run them separately, I would create two separate features. Does that make sense?
I was just sorry, I just got lost in the because I wanted to create the second polygon, but under I guess under like the previous one, right? Like like your Tahoe parking, sorry, your Tahoe Park Elmhurst. That only has one polygon, and then the other one has the other polygon plus that one.
So the Tahoe Park does not have the other. The Tahoe Park is, or sorry,
It's just that one.
double polygon is just the double polygon, and the Tahoe Park is separate. So when I select these two features on the map, it'll show me three.
Oh, sorry. Okay.
Because it's showing this one and then these two as one.
Okay.
Does that make sense?
Yes. Thank you.
Okay. Any other questions? We have a small group, so feel free to just unmute and ask if things are unclear. I'm sure multiple people have the same questions or I'm not explaining something well.
I was wondering, I live in a very remote county, and there's not actually like maps like this. It's more like Forest Service and public lands. Can you still draw it even like if I have the latitude, longitude of like where I set the trap are you gonna show there's a way for us to like figure how to like the polygram based on that?
That's a good question.
I was like wondering if I could put in my site location and then draw my polygram because I wouldn't have street names.
Around that.
Yeah.
Yeah, that's a good question. And I actually don't know if there's a way for us to input latitude, longitude on this map. I think Tim is online. Tim, do you have any idea? You might also not. Oh.
I don't actually know if that's possible either. We'll have to look into that.
Okay, we'll look into it. If you could send us an email to the help@vectorserve.org, we can communicate about it that way to make sure we get back to you. Cool. Thanks. I think I'll say it now also as we always try to. We have built and are working on improving VectorServe for all of you. We want this to be the most useful system for folks that use it. And so if you ever run into issues or you ever would be interested in a feature working slightly differently or adding features, I can't promise that we can get to all of them or will do all of them, but we're going to do our best, and we really want this to be the best system for anyone who wants to use it. So we're very, very open to feedback at any point. The help@vectorserve.org email address is the best way to reach our team, and let us know if something doesn't work or you want something to work differently, and we'll do our best to get to that. Okay, so we have, I did, I guess, just toggle here between satellite. That may be a way to help narrow in for now, but okay. So we have created our spatial features. So now we're gonna go and make our way through how to use each of the calculators. So we're just gonna go down the list and we're gonna start with Arthropod Abundance Anomaly Calculator. So let me move my stuff around here. Okay, so our abundance anomaly is basically going to calculate how many mosquitoes we have in an area compared to a 5-year average or compared to past years. So the output will be mosquitoes per trap night, as well as percent change compared to the average. So you'll see here that I have multiple agencies to choose from. That's because Sacramento YOLO, as well as the Salt Lake City Mosquito Abatement District, have given me access to use their data. You may only have one agency here, or you may have multiple if you belong to multiple agencies. I'm just going to calculate this for Sacramento YOLO. Oops. So I'll click on that. Peer agency is basically any other agency in your state. This will allow you to run the calculator on an agency-wide basis for those peer agencies. So if I'm in Sacramento and I'm interested in what's happening in the next county, in Placer County, to make sure things aren't just weird here, they're also weird in other nearby counties, I can run this calculator for all of Placer County. I can't select specific spatial features within that agency unless that agency has specifically given me access to their data in the system. For now, I'm going to skip that. We're just going to run the calculator for Sacramento YOLO. We're going to run this for last year. And our time interval. So this depends on what you're interested in and what your action threshold is. If I want to know what mosquitoes per trap night have looked like in a specific area over the last 2 weeks, I might choose half month. If my threshold is based on the week, I may choose week, or you could choose a specific date range. I'm going to go disease week. And here's where we would select our features. So this will look similar to the interface. I'm going to make it a little smaller. To the interface we just looked at with the spatial features. I could go in and create my own polygon on this map. If I was interested in this region, I could run this within that region. Or I can choose a region that I just created. So let's choose that Tahoe Park Elmhurst region to include. So here we are in Tahoe Park. Did I save that double polygon one? Yeah, so we can do that as well. And what this is going to do, if I select treat each mapped feature independently, it's going to give me two figures. So it'll give me one figure for the bigger Tahoe Park Elmhurst, as well as one figure for my other region that I selected. Or if I wanted to just run them all together, you could do that. So for example, if I wanted to run my Tahoe Park polygon, but I also wanted to add what was happening in this region to the same thing, but treat it as one to know what's going on in that whole region, I wouldn't treat these separately because I'm interested in the area. But I know I'm making that a little confusing. We are going to clear that and I'll add a separate region just so we can see what's going on. So we'll add a region way down here in Elk Grove. And what we'll do is treat those separately so we can compare what's happening in those two spatial regions. So treat those separately. Next, I will select my species of interest. My favorite way to do this is to go to species group, where you can select Tarsalis or Culex pipiens complex. Or you can go through the list and select your specific species. If you want to select multiple, you just hold down Shift and it'll select multiple species within that. For now, I'm just going to select Culex tarsalis. Again, we have the option to treat the species separately or independently or together. So if we treat for tarsalis and pipiens the same way, and we just want to know mosquitoes per trap night for both of those in a region, we might not choose to treat them independently, because we're just interested in how many tarsalis and pipiens per trap night are there together. But again, that's up to you and what works for your agency and what your action thresholds are. So we'll choose Culex tarsalis. The default sex and condition that's chosen is all of the females. Females mixed, unfed, blood-fed, gravid. I usually leave that alone, but you may have a reason to select something differently there. You can play around. And then also trap type. You can select multiple, one, whatever your agency uses. Under historical mean type, there are two options. Average is just the average. So average mosquitoes per trap night. Geometric is basically converting your data to a log scale and then bringing it back to the normal scale. The benefit of doing the geometric mean is that it basically removes any it doesn't, how do I want to say that? It limits the effect of any strong outliers. So say if one trap you collected had just like thousands of mosquitoes where all the others that you collect usually have 100, it's not going to let that one wild outlier really throw off your mean. But again, you can use what works best for your agency. So we'll just use average here and we will calculate. So this tells us there are two calculations because I'm treating these spatial features separately. So it's going to run two calculations, one for our Tahoe Park Elmhurst spatial feature and one for our Elk Grove spatial feature. So let's go ahead and calculate. So our output, and we're going to get two outputs here. One is tabular data. So basically a table. And what this is showing us is what our mosquitoes per trap night were for this this interval. So 1 week period from May 14th to May 20th, we had 6 mosquitoes per trap night in our Elk Grove. Our average, so this takes into account all the previous data that is in the system. So we have data from 2018 to 2022 for our 5-year average. It's telling us that we had a negative 4% change. So we had lower abundance in this week period in 2023 compared to the 5-year average. If we move to the next week, you can see our percent change is positive and very positive. So 780% change in abundance for this week period compared to the 5-year mean. So as we talked about earlier, when we were talking about action thresholds, I might have an action threshold that says, if I see more than a 200% change, I enact control based on abundance. So you can see that on a table. You can also download this data if you want to save it or run visualizations in another software or whatever. It'll download an Excel file. Or we can view the graphs, which is a really easy spatial way to see this, or visual way to see this. So the red line here is our the red line here is our 2023 abundance. So on the y-axis is mosquitoes per trap night. So in this week period, we collected 40 mosquitoes per trap night. So I may have an action threshold that if I collect more than 40 Culex tarsalis per trap night, I do adult control. This agency might have done control at this point and brought that number down. I don't know that for sure, but they might have. The blue line on here is the 5-year mean. So we can just see a really quick visual difference between what's happening this year. So in May of last year, we started to see a spike in tarsalis really early. So that gives us a quick indicator of what's happening and if we should enact our interventions based on our previously determined action thresholds. So I told you that we did this in those 2 spatial features. So this axis label is basically saying this is for the Sacramento YOLO Mosquito Control District. The spatial area I chose was the 2016 Elk Grove. I used CO2 traps, looking at Culex tarsalis and all of these females. When I go to the next, you'll see this is for our other spatial feature that we created. So again, Sacramento YOLO, but this is for the spatial feature of Tahoe Park / Elmhurst. Everything else is the same. On these maps, or sorry, on these visualizations, you can also click on and off other years. I'm gonna go back to where there's probably more data. You can turn on and off previous years. So if I just want to see 2023 versus what happened in 2022, I can just turn on those 2 years. Whatever is most useful for you. You can mouse over any of the points and it'll tell you the mosquitoes per trap night for that time period. And you can screenshot these, which can be used for board reports or whatnot. So that is for the abundance anomaly calculator. Any questions on the abundance anomaly calculator before we move on? Great. So next we'll move on to the pool infection rate calculator. You'll notice a lot of these look pretty similar. So the pool infection rate calculator estimates the arbovirus infection rate based on testing pools of mosquitoes. So this is based on the CDC's maximum likelihood estimate, minimum infection rate, Excel add-in. So if you prefer to use an Excel add-in to calculate these things, by all means you can. But this calculator is based on that as well, so you will get the same outputs. So the choices here are somewhat similar. Again, it's showing whatever agencies I have access to. So we'll use Sacramento YOLO. I'm not going to choose a peer agency. We can choose a date period. So I'll show you a couple different ways here. So this one looks a little different than the than the abundance anomaly calculator. If I was interested specifically what was happening in one disease week in 2024, so let's say I was interested in what was happening last week. So this week I could just run this pool infection rate calculator for that 1 week period of 2024. Now, if I was interested in the couple weeks prior, that's what this number of date periods means. If I have it at 1, it's just going to calculate for that 1 week. When you increase this, it's basically going to go back in time for the same time intervals. I know that's a little confusing, but say I click 4 date periods, it's going to give me 4 weeks. So it's going to give me disease week 24 as well as 23, 22, and 21. You may be interested in this on a 2-week period, a half-month period. Maybe your action threshold is we enact control when there's more than 6 positive, 6 infected females per 1,000 tested in the 2 weeks prior. So you may want to run this on a 2-week scale. So let's just do that. we're going to use half months. We're going to look at this year. I haven't looked at this, so I don't actually know what's going on. We're going to do June. And if I was interested in the couple months prior to June, I would choose the amount of date periods consistent with that. Since I'm using half months, this will be 2 date periods per month. So if I chose 2, it would give me the 2 half-month periods of June. If I choose 4, it'll also give me what happened in May. This should be low because we're just starting to find West Nile positives. So I'm actually going to move to last year so we can actually see some data on here. So this will give me 3 months because I'm using half months. So it'll give me August, July, and June of last year. I can choose my spatial features that I'm interested in here. I could also do this based on specific sites. So if I was interested specifically what happened at one site in this date period, I could do that. I'm going to choose a spatial feature. We'll choose Elk Grove again. We'll just do one this time. So there's our Elk Grove spatial feature. Our target is West Nile virus, but if you have something else circulating in your area like St. Louis that you're interested in, you could also move to that. Here I'm going to look at what's happening in Tarsalis and in Pipiens, but I'm going to treat each of these separately so that I will get 2 outputs. I'll get what the infection rate in half-month periods were for Tarsalis and what the infection rate for Pipiens was. I'm going to just stick with CO2 traps, but your agency might use different ones, or you may want to compare what's happening in CO2 versus gravid traps or whatnot. Now, the point estimate is what we talked about at the beginning of this session today when we talked about there being multiple ways to calculate pool infection rate. I'll just mention them briefly again. The minimum infection rate is calculating if a pool of multiple mosquitoes test positive, it's assuming 1 mosquito out of that pool tested positive. So at a minimum, there's 1 positive out of how many mosquitoes were tested. The maximum likelihood estimate uses statistics to allow for that number to not just be 1. And it takes in information such that as the season progresses, there is possibility of more than 1 mosquito being infected per pool. It also gives us confidence intervals. So it gives us what the minimum and maximum number of mosquitoes with 95% confidence in that pool tested positive. The bias corrected maximum likelihood estimate is I can't remember exactly. I think it's works really well. I thought I had this written down, but I can't remember why the bias corrected is better. I will have to look at that. But our default is the bias corrected, and I know that it's the one that's preferred. I think it works well when the data is sparse, but will also work when there's a lot of data in the system. Confidence interval, you probably want to leave at 95, which is common in statistics. That's going to tell us with 95% confidence, the number of mosquitoes infected is between this minimum number and this maximum number. So in here, we have 12 calculations because we're doing a calculation for 6 half-month periods, and we're also treating our species separately. So that's doubling our number of calculations. So we'll go ahead and hit calculate. That was pretty quick. You can see on our output here, this is separated by the species that I chose. So it's telling me the point estimate. So how many mosquitoes were infected per 1,000. for each of these species. So in this half month, the first half month of July of last year, the maximum likelihood estimate was 2.3 infected females per 1,000 tested. And here are our confidence intervals on that. It could have been as low as 0.1 mosquito infected or as high as 11.3 mosquitoes infected. We can also view this on graphs. So here is for Culex tarsalis, showing us our point estimate. So 2 mosquitoes infected per 1,000 tested, with our confidence intervals here. And so your action threshold might be, we do adult mosquito control when more than 5 mosquitoes test positive out of 1,000. Your action thresholds might also have some stipulations with confidence with the confidence interval. So if the maximum possible is above 10, we enact control. Again, it's based on whatever your agency specific action thresholds are. When we click through, we can see what was happening in pipiens. So we saw infection later. They may have done control based on this infection rate and knocked that down. When they did control of the adult infected mosquitoes, it brought down the infection rate. Any questions on the pool infection rate calculator? One last thing that I didn't show you is that we have the scale set to 1,000. So everything I've been saying to you is, for example, the action threshold of more than 5 mosquitoes per 1,000 tested. If I wanted that as a percent, I could change the scale to 100. And let's recalculate that. And so now we're getting a percent. So this is the same thing. So this would be 5 mosquitoes per 1,000 or 0.5%. So 0.5 per 100, whatever works for your agency. Awesome. So we will move on to the vector index calculator.
Olivia.
Yep.
I just wanted to ask a quick question. It was interesting that over time it looked like those confidence intervals got wider. Is that sort of a function of just there were more captures? What do you think that was about?
Good question. I wish I still had it up, but that's okay.
Sorry.
No, not your fault at all. For my sake. I think it's based on probably how many were tested, and just the amount of data. I think when you get more and more pools tested, there's going to be more and more uncertainty, right? Because if I have 50 pools of 50 mosquitoes, and each of those tests, or I don't know, half of them test positive, within each of those 50 pools, it could be 1 mosquito or all 50 that are testing positive, right? So
yeah, that makes total sense. Yes, thank you.
Yeah,
Yep.
Great. Okay, so we'll move on to the vector index calculator. So the vector index is combining abundance and infection. So it basically takes the first 2 calculators and blends them into one to give you a relative abundance of infected mosquitoes. So this is a good way to quickly estimate the risk of arbovirus transmission in an area. So increases in vector index reflect increased risk of human disease. So it's a pretty good prediction measure, and more reliable than just relying on abundance or infection alone. Of course, it requires you to have both abundance and infection data. So do the best that you can. If all you have is abundance data and your agency isn't funded to do arbovirus testing, then we're going to set the action thresholds based on abundance data. But sort of the gold standard is vector index because it does take into account both abundance and infection. So again, things are going to look somewhat similar here for this calculator. We're going to run this for Sacramento YOLO. For last year, we're going to do a disease week interval. And again, we can choose spatial features or draw them ourselves. So we're going to do Elk Grove again. The nice thing about, you can see here, the nice thing is if you create these spatial features and save them to your account, you can just run them week over week instead of having to draw them every time. Our target here is going to be West Nile virus. Species that we'll look at Tarsalis and Pipiens again, and we'll treat them separately. We're going to leave this to all females. We're going to again look in CO2 traps. And here's our trap night restrictions. And the reason that is there is for you to exclude traps that may have ran for longer. So for example, if in this area, most of the traps that I run are for one night, but I have some long-term surveillance traps that run for 5 nights, 2 weeks, whatnot. I don't necessarily want to include those traps that have run for a long time because we might not have A, been testing those for arboviruses, or B, it's gonna the likelihood of finding arboviruses in mosquitoes that have been in a trap for 2 weeks in the hot sun is probably pretty low, right? So we might want to exclude those traps that had high trap night numbers. Again, that's up to you and what works for your agency. The default is minimum the trap ran for 1 night, maximum it ran for 2 nights. I usually leave it at that. Again, same point estimates as the infection rate because this calculator is using that infection rate and multiplying it by abundance. So we are going to calculate. One thing I want to point out is with these calculators, as you're running them, you'll see that it's allowing for up to 600 seconds, so up to 10 minutes for the calculator to run. None of them should take that long, but if you went through and you selected every species and treat each one separately, every trap type, and you ended up with like a ton of calculations, it might take the calculator quite some time to run. It'll time out after 10 minutes. I wouldn't expect that you'll hit 10 minutes, but maybe. Okay, so again, we get a table output here for our vector index. So we are looking in CO2 traps for Culex tarsalis, all females, disease week. So our vector index for all these disease weeks in May, June, 0, because nothing's testing positive. It's still giving me abundance, so mosquitoes per trap night over those weeks. So we can see that, but nothing had tested positive, so our vector index is still 0. We get into July and we start seeing positive mosquito pools and therefore positive vector indexes. So this is telling me that 122 mosquitoes per trap night per 1,000 tested are positive for West Nile virus. So to make this a little easier, let's look at a number like, let's say the number is 406. So this is saying 406 positive mosquitoes per 1,000 tested per trap night. So that a number of 400, we're scaling by 1,000. So what 400 means is 0.4 mosquitoes per trap night are testing positive. So we can look at that on a graph. So we'll pull that same, this was our 400. So this is saying 400 mosquitoes out of 1,000. So 0.4 mosquitoes are testing positive. So again, this is an easy way to see if your action threshold for your agency is above 300 per 1,000, then you might enact control during this week after you saw that high vector index. You can again compare to other years if you're interested to play around with there. One thing I want to point out is if at any point you're confused by how to use any of these calculators or what the output means when you see that number 400 and you're like, I don't remember that that's 400 mosquitoes per 1,000 per trap night. All of the calculators have this little help icon at the top right. When you click that, it'll take you to the VectorServe documentation for that specific calculator. So if we go to that documentation, it's going to tell you what vector index is calculating, how it's calculating that, what all of the fields mean, how to use the spatial features, again, what the other fields mean, how minimum infection rate, maximum likelihood, and bias corrected. Here now I can confirm that I think I was correct, yeah, that standard MLE can have bias depending on quantity and quality of data. So bias corrected is recommended when sample size is small, but it'll be appropriate for most situations. It'll also tell you how to interpret your results. If you don't want to get there through the question mark on the VectorServe, or sorry, on the gateway calculators, you can go to just, it's vectorserve.org/docs. That's our full documentation page. And over here on the right is a scroll bar that will show you the documentation for everything that's in VectorServe. So for each of the calculators, I could specifically select vector index and it'll take me back to that documentation for vector index. There's a question, can we add the thresholds to the graphs? And I think that's an excellent question and idea. It's not something that you can do currently, but I think it's a great idea. I'm not a developer, so I don't know if that's in the works, but it's definitely something that I think is an excellent idea, and I am writing down to see if in the future that could be something we could do.
Another question.
Yeah.
I know you said that the thresholds and the are all dependent on which agency, like whatever we input and say, but where do we input those thresholds?
Oh, sorry, that's not built into the system. That's just going to be based on whatever your
Oh,
agent.
we do. Okay.
I think that is something we are going to work toward being able to do within VectorServe. It's just not something that we can do right now. But
So okay.
Go ahead.
So when we look at the graphs, and they're either green, the numbers, which are either green, sorry, either red for being like, yo, this went up, 500%, or like blue. Those are based on like who inputted those thresholds so that those.
That's a good question. I think red just means increase. Well, I don't know. I wonder if there is some base threshold that's built into there, but I don't actually know. So that was for like the abundance. Let's just go really quickly to that. Yeah, so you're talking about here.
Yeah.
Yeah, so it looks like
the percent
probably
change,
above 50. I don't think that is something you can change right now. Let's see if Tim is still here. He might not be here anymore. Yeah, that's something actually, Tim's not here, so he can't respond. I'm not sure that that's something you can change, but it's something you should be able to change. So I will look into it. Cool. Thank you for that feedback. I like that idea a lot. Great. Okay, so those are the abundance, pool infection, and vector index calculators. Those are the thresholds that we talked about at the beginning of the training today. Next, I'm going to show you this risk assessment calculator, which I think is pretty amazing. So this risk assessment calculator is based on the risk assessment model found in the California mosquito-borne virus surveillance and response plan. So this is based on a California model, but that doesn't mean that it can't be helpful to other states as well. It also tells you what the environmental data that is pulled into this calculator, where it's from. So basically what this risk assessment calculator is bringing all of this together. So just like vector index was bringing in the two previous calculators, so the pool infection and the abundance, this is bringing in vector index and other information. So it's bringing in environmental data, it's bringing in bird surveillance data if you have it. So it's bringing in positive dead birds, and it's bringing in any seroconversions of chickens if that's something that your agency or state does. This calculator still works if you don't have that information. One huge benefit to this calculator is that it pulls in that environmental data, so temperature and precipitation, and it adds that to your vector index to project or to estimate risk of West Nile at any given time. So I'll show you how this works. Again, pretty similar. We'll run it for Sacramento. We'll run it for 2023 disease week. We'll run it in Elk Grove. Now here we have some decisions to make or to leave alone. If you ever hover over something, you don't know what it means, it'll explain it to you. So this buffer distance is saying the distance outside the specific region encompassing the broad region. So I know that's kind of vague, but basically what it's saying is let information from the broad region of 150 miles or 241 kilometers, let data from that broad region affect what the estimate of risk in this current region. So for example, if 50 miles away there was a dead bird that tested positive, that could increase my risk in my region. So strongly encourage just leaving 241. This is again based on the California response plan, which I have the link that I will put in the chat after we go through this. So recommend not changing that, but do what you got to do. We're going to look for Tarsalis, females, CO2 traps. Again, this is that geometric versus average mean. Geometric meaning that it's going to transform to the log scale and then bring us back so that any really strong outliers aren't going to affect our estimate. And then our carcass period here is the number of days considered for carcass infections. So is basically saying how long to let carcass data, so dead birds or seroconverted chicken, how long to let risk persist after a dead bird has tested positive. So I just leave that usually what it is. This calculator can take a little bit longer because there's a lot of information going on. While that happens, I'm going to put into the chat the risk surface methodology from on the VectorServe documentation. So if you're interested specifically in what goes into this calculator, you can find it on that, as well as a link to the California response plan. I'm confused by why it started and stopped. That was weird. Weird. I don't know why it's just stopping. We're gonna reload real quick. Weird. Year 2023. Half month. Grove. I'm gonna include another species group. Tarsalis. There we go. Okay, so the output on this risk calculator is going to show us by disease week, because that's, or sorry, by half month, what the risk is for West Nile virus. So if we hover over, it's also telling us what date that half month corresponds with. So it gives us an overall risk estimate. So as the season progresses, risk gets higher until it gets later in the season and it gets lower. And it'll tell you everything that went into that overall risk estimate. So just for environment, as we get to peak temperatures, our risk is going to get much higher just based on temperature data. And then this will take into account your abundance data. So how many mosquitoes were collected in this area over each half month period, what the infection rates looked like of your mosquitoes if you do arbovirus testing, seroconversion of the chickens if those are tested in your area, as well as dead birds. So when are dead birds testing positive for West Nile, and let that affect our risk as well. So this will give you an output for a risk estimate for West Nile in this half month period. Now, I told you that this was based on the California response plan, and that's what these numbers are derived from. So in that California response plan, I don't remember exactly, but I think below 3, it's normal season. I think red is elevated orange is elevated, and red becomes high risk. And in California, based on those numbers, we have how we should respond to that risk. So on that risk methodology, risk assessment surface methodology, that's all laid out here if you're interested in exactly what's going into that risk calculator and what it all means. Here's what those are. 1 to 2.5 is normal season, 2.6 to 4 emergency planning, and 3 is epidemic. So above 4.1 to 5 epidemic response level in California for those regions. This risk calculator, where are we? Risk calculator also has a corresponding map. So I'm going to show you that briefly on maps.vectorserve.org. You have to be logged into your gateway to be able to see this. Too many things open. There we are. So our West Nile virus risk map is basically that calculator running under the hood. So if you just want to look at this on a wider scale, without making those decisions for the specific spatial regions, you can do that. So this will show for other states as well. So for example, in Utah, it's showing based on the data that they have collected. It's just applying the California response plan. So you can use it or not, of course, based on what you have and what you want in your state and agency. So this is showing, you can break this down by overall risk or each of the individual risks. So if you're just interested in what the temperature is doing for risk, you can break those down. You can also look by species or species complex, so Tarsalis or pipiens. And you can look for a specific agency if you would like to. So it'll show me for Sacramento.
I have a question.
Mhm.
So there's no code for no data? Maybe in California you have, pretty even sampling across the entire state, but we don't have that in Maine.
Yeah. So I think it's only showing where there is agencies and data. So on these maps, the agency boundaries are on here where there are agencies, and then it's only mapping where there is data.
Okay, so I'm just, in my mind, I'm saying just because we don't see a lack of risk in an area, it doesn't mean there isn't risk. It's just no
Yeah.
information, maybe?
Yeah.
Okay, thank you.
Yeah. I think that yes, exactly. And so what's happening here is if there's no data for any of these specific things, it's not going into the calculator as well. If you click on specific agencies, you'll also get a chart that pops up showing you over time what that risk looks like for that agency. Okay, so we have gone through, let's close some of these things. Might make me re-log in because I went to the gateway. Okay, so the last tool that we're going to go over today, I know that this is a lot of tools, but the last one we're going to go over today is the bottle bioassay calculator. We all know that insecticide resistance is a major issue that we are combating and overcoming. And so we have a resistance module in the gateway and a bottle bioassay calculator, which basically, if you're doing bottle bioassays, it will create the charts for you based on the information that you put in. Not much to show you here. It's basically showing for any bottle bioassay that was added in my state, I can choose to view those on a chart. So the calculator is basically select any bottle bioassays that have been inputted into the system, and then we can get KD50s, KD95s, and see over time what the knockdown looked like for any of those populations and whatever active ingredient they chose. So the benefit of this is just it'll make the charts for you. You don't have to do this or use an Excel spreadsheet to do it. The bottle bioassay calculator also has a, bottle bioassay resistance also has a corresponding map, which will show you where bottle bioassays have been done, which active ingredients and whatnot, so you can see what's going on near you and maybe give you some input into what testing you should be doing as well. There we go. Okay, so I'm gonna turn off these pesticide controls. This purple in California is showing pesticide use reports, but it doesn't exist in other states. So we're gonna turn that off. This map is showing us where bottle bioassays have been conducted or resistance testing in the US. And you can set controls here of what you want to look at. So if I'm just interested in what's happening in specific species, in pipiens, complex, and Tarsalis, and I'm only interested in what is happening with deltamethrin, for example. I don't know why you would just look at that, but you can turn on and off certain active ingredients and species to see what resistance profiles are looking like where tests have been done. And you can also change by mean percent knockdown at say 15 minutes or whatnot. So this is showing like most of these mosquitoes were knocked down by 15 minutes, so pretty susceptible. But again, based on what you're interested in and what your action thresholds or whatnot are. It's just a way for you to visualize your data and see what's going on in your area. Sorry, I said that wrong. That mean percent knockdown at, okay, mean percent knockdown at 15 minutes. All of these were not very knocked down at 15 minutes, but by later. So we're seeing resistance, you know, in certain areas and not in others with different products and different species, but a way for you to visualize what's going on and also to help you make decisions on what insecticides to be using, so that the control we're doing is actually effective.